Hello, everyone, and welcome to today's webinar. This is Chalmers University of Technology, as you already know, and we are going to be talking with the program director for the master's program in high performance computer systems. His name is Pedro, and I will not try to say the rest of his name because it's pretty long and he has pretty interesting background too. But before we start the presentation, we are actually going to just quickly run through the rules of the webinar, the housekeeping rules. This webinar is being recorded, as you might have already noticed. Please use the Q&A section to ask your questions. The chat is actually closed. On the Q&A section, we would like you to ask your questions only once and ask them as clearly and with as much detail as possible. This will help us answer your questions better and answer as many different kinds of questions as possible. You can also comment on the questions that are being asked. So you can comment on your own question or other people's questions to enable us to better understand your question or answer different angles to those very same questions. Only relevant questions will be answered. We will not be picking up any questions about documentation or deadlines or application processes and things like that. This webinar is specifically only for the master's program itself and the content thereof. We will be answering questions by voice and by text. I have my colleagues with me, both Cecilia and Vedrana will be moderating our questions today. And you will, of course, see the contact slide at the very end, which will help you determine which channels you can use to talk with us. But without further ado, I hand it over to you, Pedro.
Thank you, Avilash. So it's a pleasure to be here, and thank you very much for inviting me for this webinar and giving me the opportunity to talk a little bit about the program. So this is a new program. We just started last year, so we are on the second run right now. The title of the program, as it was shown already, was High Performance Computer Systems. And I am the director of this program. I'm also an associate professor at the Computer Science Engineering Department. And before we go to the presentation, just to give a quick overview, I come originally from Portugal. I went to do, well, I did my bachelor's in Portugal in engineering. And then I went to the US to do my PhD in the University of Illinois Urbana-Champaign, where I spent there 5 years. Then I went to Cyprus, which is a very hot country in Europe. I was serving there at the university. And 4 years ago, I joined Chalmers. So I go around the world, and right now I'm in this very exciting place. And I hope to see many of you come here too. So we can start now. I would start with a question. So what is high performance computer system? And unfortunately, we are not here face to face that I could go around you and shake you a little bit and get an answer from you. But given that you are here, you're probably interested in this. And if you are interested, you could kind of come up with this answer that if it's high performance, then it's something really big, something super. So would it be a supercomputer? Well, I don't know. What is a supercomputer? So yeah, maybe it's a supercomputer. Is a super person with a computer? Is this it? No, well, that's not a supercomputer, but we can show you some pictures of a supercomputer. So these are 3 supercomputer systems. Actually, the one on the right is hosted inside a church. It's a very interesting supercomputer center in Barcelona. If you have a chance to visit it, it's great. And these are huge machines that do solve the most complex problems that we have right now. Okay, so we are doing a lot of simulations these days, a lot of, for example, I mean, I don't want to be very cliche, but we are going through this pandemic. One of the huge efforts was to design a new vaccine. And vaccines do require to be, in order to be designed and be effective and predict how to do this, they need supercomputing power behind this. And we all know these things. So these machines, super important, and they are important to solve a huge range of problems right now. But for our program in particular, what we are interested is in seeing this capacity of computation. And now we need to look into it. What we want to do with it is shrink it and actually be able to deliver it in very constrained devices, for example. And I'm showing here a drone. So you want that huge computational power inside a drone that will self-drive itself in situations, and it could be a rescue situation where it's not easy to control it, you're far away, and it will have to take decisions on its own. So we needed all this capacity, very small space, and another very interesting constraint is it's battery powered. You cannot have a cable to this. So how can you achieve this? So this kind of makes us see what are the trends in the field. So so today and the future, what are the issues going on here? So high performance computer systems, like we said in the previous slides, supercomputers, I want them in the small boxes though for our cases. And this is required in key aspects of our life today. So for example, and this is something that we can relate because we see these news all the time, autonomous vehicles, right? So machine learning is a huge driver for all these things. We need a lot of computational power inside our vehicles to self-drive and do all the operations that need to be done. This is a humongous thing. And vehicles are not plugged to the electricity cable. So you need to do them on battery on the move. And you don't want to reduce the range of the car. So it's very important to be very compute power, but very efficient while doing this. And the other side are data centers and IoT. So from the small Internet of Things devices that are now smart everywhere. We have smart homes, we have smart industry, we have everything is being intelligent. We need this intelligence on the device, on the sensor, cameras that are smart, up to big data centers. So this all, we call it the computing continuum, needs to be very powerful, but also very efficient and be able to analyze huge amount of data. Okay. So then what is unique about our program and the people that we are educating within our program? So there are programs that focus on advanced hardware, and we have very good programs in Chalmers to do this. And then we have programs that focus on advanced algorithms. And again, we have very good programs doing this here at Chalmers. But what we want out of this particular program is to educate people that can talk both languages in both worlds, communicate up and down decisions, so that we can transfer this knowledge around from hardware to software, software to hardware, to something that is key today, which is called co-design. So in order to get the best solution of a whole system, we need to be able to adapt both the hardware and the software to work together. We cannot be in two different worlds. And this is what we want out of this degree and the people that we are educating here.
Pedro, can I ask you another question?
Yes.
So I mean, not another question. This would be my first question, but the question is, we spoke about the student profile here and what kind of students we produce.
Yes.
As in the student we produce would be somebody that speaks both hardware and software, yes, so to speak. What kind of student profile would you think fits the program to start with?
So I have this on the last slide of the presentation.
Yes.
Which was, I just wanted to motivate people right now for what they will become. And then I will say, but to enter, you need to be this. But so I think I will skip that until
we will get to it. Yes.
Yeah, we will get into that. Yeah, but good point. So what are the challenges and what are the goals that we'll achieve? So to summarize in a different way is that we want to design both software and hardware for the demanding constraints, meaning not just performance, because in the old times was just make it faster, 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 but that's not it. So what about power and energy constraints? And we talk a lot about sustainability also, and there is going to be a slide on that later on. But this is not just the sustainability, which is obviously a very important thing, but also because we are shrinking this into devices that cannot spend so much energy. And optimizations across the different layers of the system. So in the old times, we like to chop things up and have people inside their own boxes. And now we are saying, now you need to just talk through all these layers and be able to develop and exploit systems. Systems today, I mean, if you are in the field, you know that you can buy a whole lot of devices, many companies producing many devices. How do you exploit the performance that these devices can give you is also an issue that we address in this program. And then we have a special bullet here that I will develop a little bit later on, which is if you have great ideas within the program, then we can give you the tools to bring these ideas to the market also, which is a unique thing from our program actually. But we'll go back. So what I can summarize this is, if you come to Sweden, you'll see that many days they are gray. So there are these challenges, this gray cloud, and then we have the holistic view that we are saying here, which is the bright sunshine, which today there is a bright sunshine. So again, unique features of the program are, well, we will be able to give the tools for students to develop skills to utilize to the full potential the systems that are available, and also to develop new systems, but meet the demands that are put into us. And interaction between the different layers of the system, like I said before. We offer specialization in 3 key areas, which is computer systems, computer graphics, and real-time systems. And I'll go also in more detail when I present the courses. In addition to this, and I was mentioning already before that we have a special set of tools to help people bring their ideas to the market. So we have a track specialized in entrepreneurship, and more details also in the next slide, and opportunity to work with top faculty researchers. So the father of this program is actually one of the top people in computer architectures in the world, Professor Per Stenström. He would be the professor teaching your course in your first study period, so introducing you to the program, which is fantastic and a unique opportunity. And also, in addition to this and all the other great faculty members that we are involved in many top research projects. One of which, I will also again talk more about research projects later on, but one that I want to highlight is this European Processor Initiative, where we are designing a processor in Europe for Europe. And obviously, another unique feature, not unique because all the programs do, if you see the other webinars for the other programs, Chalmers is located in a wonderful place with many industrial partners around, and we had the greatest opportunity to talk to many industrial partners and try to get input for our program. So we are trying to deliver what they are asking for the people to go to the jobs. So going a little bit more into the details of the program. So here is a high-level overview of our program. So you start with some core knowledge in the first study period, where we have 2 courses that are compulsory and introductory to the whole topic of the program. This is computer architecture and high-performance parallel programming. This is not your usual parallel programming course. We are looking for performance in here and efficiency. So those are the things that we look into that. Then we also have a general skills course helping students into getting skills into writing, presentations, ethics, and many other generic skills that are, we call them soft skills, to have the development of the profile of the student that we want to deliver out of the program. And inside this center core, we have here the 4 tracks, which is computer systems, computer graphics, real-time systems, and then the entrepreneurship. And we'll see the courses that are inside each of these tracks. After you're done this and you get the knowledge necessary, you will be part of this master thesis project, where you'll develop more your knowledge into one of these areas. And if you do get into the entrepreneurial track, you get a chance to bring your ideas to the market. And this is a very exciting thing that we are actually having right on. And I'll develop a little bit more now. So in terms of courses, if you go to our website, you will see this diagram, which is a very nice diagram. Looks like these little pieces, like a game, right? So the cool thing is, at the beginning, you don't need to choose, so you can relax. There are 2 courses, like I said, these are the core courses: computer architecture, high-performance parallel programming, and then the fun starts. And by fun, I mean you have the choices to get in one. Well, you have to do 2 out of these 4 tracks. And the first track is computer systems, And this is composed right now by the Sustainable Computing and Parallel Computing Architecture course. And if you can change the slide, please. I have breaking news for this track also. New in 2021, we will have a new course. This is called Reconfigurable Computing. And if you know what the FPGAs are, so a type of hardware that you can configure and adapt to a specific task. And these are actually this type of hardware, and the knowledge it takes to develop this type of hardware is extremely important for small companies, startups that want to do some sort of prototype for their products. And in particular, when I went around industrial partners to join what was presenting our program and get more feedback, they were saying, please give us more people with FPGA knowledge. And therefore, we are listening to them and delivering this extra course for our program. So the next track is computer graphics. And here we have computer graphics, computer advanced graphics. And the students in these courses do get a chance to collaborate with top researchers in this field, and they do super exciting projects. So my field is computer architecture. I'm more working on the machines, and these colleagues are doing these cool game engines and the nice images and 3D rendering of stuff. So really cool things. I have seen some master theses that actually students produce code that is then integrated into computer games, for example, and it's very exciting. The other track is the the real-time systems track. So we have real-time systems and dependable real-time systems. This is extremely important for devices like the drone I was showing you and the self-driving cars, where decisions have to be taken within a specific amount of time. So in sustainable computing, we talk about efficiency. Here is not just efficiency, it's timing. So decisions have to be done within a specific time, and this is very hard to deliver. So it's also very exciting to work into this field, and it's very demanding for right now, and how much computation we need to do within this fixed time. And last but not least is this unique track that we were the first program to have it introduced. This is what we call the entrepreneurship track. Two courses with very long names, so strategic management of technology innovation and creating technology-based ventures. In short, the first course is looking on how you can create value, because entrepreneurial mindset is creation of value. How you can create value within an existing industry, an existing company. The second course is more looking into how to do a startup. But I want to emphasize here that entrepreneurship is not just about doing startups. It's about creation of value, and creation of value can be within the company. It's also a mindset. It's a lot of other things that are extremely important for the preparation of students for the current world outside that is expecting you. We are doing this, obviously, we're not experts in entrepreneurship, but we are doing this in collaboration with the Technology Management Economics Department. And one cool thing that we have, and this is starting this year with the master theses, is we are pairing up. So master theses in our program, just like many other programs, are done in teams of 2 students. But we are pairing 2 students from the TME department, the economics department, and 2 students from the HPC program. And we are doing a super team of 4, where the HPC students are developing a product within the masters that I have just described you. And the TME students are helping to launch this product to the market. So in an ideal situation, at the end of the master thesis, we will have all the plan to create a startup for this particular idea. And we actually are having right now running one master thesis project like this as a pilot. So I find this extremely exciting. If you look at the classes there, that I'm showing from the different tracks, you can see a similarity if you know anything about this. I mean, I know I'm old, but this retro game called Tetris was about plugging in pieces. And if you see now, you can see that these courses are like Tetris pieces. And the reason for this, that we designed it like this, is to give opportunity to the students to actually take all the 4 tracks if they feel like it. So you are just required to take 2, but we designed the Tetris so that you can take them all 4 and enjoy. So, but these are the courses that are core courses and what we call the track courses, so for specialization. In addition to the specialization, can we go to the next? Yeah, we have the electives. And this is an opportunity for you to broaden your knowledge. So I wouldn't say this is for you to take more courses in what you're interested, but also an opportunity to get exciting other topics that we have here at Chalmers. So I'm not going to describe these things here, but one of the really cool things, for example, we have at Chalmers, we have one of these flagship projects on quantum computing, that Chalmers received a huge grant to build a quantum computer. And there is actually a quantum computing course that you could take among these electives. So you can take a course on security, on cryptography, that is a very hot topic. You can take a course on how computation is used in biology or physics, and many other courses. Other interesting courses that we have is you can take something that is, again, one of these efforts from Chalmers, the tracks, which is a course that will be a little bit more flexible and multidisciplinary. So you get a chance to work with students coming from other programs, working together on a project and contributing with your knowledge towards this team. So you get a different type of experience. And in addition to all this, we also give the opportunity for students to go to other countries in exchange student programs, which is, again, an excellent opportunity to meet new people, see new cultures, and so on. So lots of cool things to do. Yeah. Now, in terms of industry, so what is the relationship of the program with industry? So we have industry contributing to the industrial board of the department, and actually also for consultation, like I mentioned before. I went around the companies, knocked at their doors and said, okay, what would you like to a student to, you see our students coming out from Chalmers, what are you happy, what are you not happy, what would you like more? And we work together with them. In addition to this, obviously, I mean, they also offer jobs to our students, and very importantly, they offer internships for them to try out if the students really want to do the job with this company. And a way to learn more about what they do is by inviting them to give seminars in our department, which we do, and actually guest lectures at courses. So for example, the course I'm teaching, which is sustainable computing, we have the last week is like workshops where we have guest lectures from the industry. We got people from Ericsson Research and from other startup companies that actually I'll show here the logos. These are the, we have contacts with many more industry partners, but these are the ones we have tight collaboration with. So 0 Point is a startup company doing memory compression. Ericsson, you know the company, obviously, and we work with Ericsson Research. Embeddle is for deep learning, and MCs also, they do hardware for deep learning. Volvo, obviously, we are in Gothenburg, which is Volvo City. So there are lots of projects with Volvo. And one thing that I forgot to say is that another great opportunity that you have in Chalmers is to do your master thesis together with one of these big companies. And they give very exciting projects and give you the opportunity to do a test drive to see if you really like to work for this company or not. So I think that's very good. And you do solve real world problems, which is, again, an important thing. But industrial theses are not the only thing we do, right? So if we go to the next one. So just to have an idea of the program, so in 2019-20, which was our first year, we had 30 positions open. We increased to 40, and we are planning to continue to increase this to more positions. But we want quality and not quantity, so we are going slow. This is the way that the new program should build upon. So being careful and developing slowly and improving every time, doing iterations on this. In terms of master theses, because I was talking to you about this, so this is the snapshot of today, what is happening today. So we have one with the entrepreneurship that I was telling you about before. We have 5 industrial theses with different partners like Volvo. RUAG is for space, aerospace industry, Embeddle for the deep learning I told you about, and Koppen Geisler again for aerospace processors. And then we have 8 projects that are basically research. So this gives me a link to talk a little bit more about research. What do we do as faculty? So you probably know that as faculty, we do teaching because this is the interface you see. And then behind the scenes, we spend our days and nights doing research. And research is together with our PhD students, master students, and by ourselves with collaboration with other colleague scientists in trying to solve, for example, the problems that will happen in the future. So what we are trying to do in our program, the faculty that is involved in our program, our specialization is in computer architecture, for example, just like myself. And we have many topics that I've listed here, but I'm not going to go over them. But processing in memory is a very interesting topic that we are starting right now. So you know processors, you know memory, but right now we want to mix these two things together. What can we do for our systems to be much better in the future? And so we are involved in different research projects. These are several of our European research projects that we are involved. So the European Processor Initiative, I told you, is a very big initiative from the European Union, where we want to have a little bit of independence from the American, Chinese market into terms of hardware. So if we want to be independent, we have to design our own processor, and this is what we are doing in this project. VEDLIOT is a project that I'm actually the PI for Chalmers, and in here we are working for IoT devices for deep learning. And in particular, we will be designing one of these future deep learning accelerators that will be super efficient and co-designed with the team that does the development of the algorithms. Legato was looking at energy efficient solutions, and Sharks on reliability, EcoScale on scalable systems. The one without a name is called Pride, and this is a Swedish project that was just recently approved for processing in memory devices. And HiPic is actually very interesting, is a network of excellence. What this means is that it has many partners from Europe, and we work together in terms of getting into conferences together, giving also sponsoring exchange of researchers around the network and many other research-oriented activities for the students. So also opportunities. Okay, so let me be a bit more general. So this is usually the starting slide for many of our Chalmers presentations, and obviously sustainability is a big thing in Chalmers, and I'm very proud that I'm part of this. But I'm using this slide usually just to tell you, even though we are all at home right now and this is a virtual background, that's my office over there, and I miss it, but one day we'll be back there. So I hope you get the chance also to visit us soon at some point, and you will be meeting me there. In terms of Chalmers also, Chalmers invests a lot in what they call areas of advance, and our program, I wanted just so you have an idea, is positioned inside the ICT area of advance, okay, where we are looking at the information technology, and we work together with the industry. And the goals that are pointed in this area of advance are pretty aligned with the goals of our program, like big data, data sustainability, connected worlds, right? And then just to place you a little bit closer, so we went from Chalmers, the areas advanced. So in the next slide, I can show you that we are part of the computer science and engineering department, where we conduct like I say, is basic research on a wide range of areas. And you have the same picture that we have in our program there with a supercomputer, but there's robotics and many other things. And the 2 pictures on the bottom are from our 2 campuses. So I belong to the computer engineering division, one of these divisions that we have within the department. And I think we go now to your original question, which was, who do we want to attract for our program? And I wanted to introduce this by showing, again, one of the important efforts that Chalmers has is by introducing this concept of entrepreneurship and entrepreneurial mindset at all the levels of education, from the bachelor to the master's and so on. So, and entrepreneurship has to be seen here as creation of value. So not necessarily you are going to create a company, a startup, but creation of value. And this can be for many, many things that can be done. But it's important that you are able to get the soft skills to solve problems within certain time, within certain pressure, without having too much directions, and produce value to somebody else. And these are very important skills that you need today to handle. So if you ask me who I would like to have in the program, I would like to have students that can embrace this concept of entrepreneurial and growth mindset. So be able to fall, come up, fight for what you want, and come up with great new innovative ideas to solve and give value to other people. So that's my generic answer. And with that, I wanted to link to an effort that is aligned to this so that you can see what I mean. So in one of my courses, I give them as a voluntary project. So this is not mandatory so that people can do it on their own will. I introduce them a concept of doing a video with the concept of the course that is taught in the course, but it's totally free. I don't give any directions. I don't give any instructions. This is for students to develop their creativity and explore and show us their best. I call this thing 2-minute Teach Me's, and instead of a YouTube channel, we have our own private video setup. So I have this in the Chalmers Play channel, and we post these videos from the students within here. And these are student-created videos, so value creation for other students and now for you. So, and if I can get your help now, maybe we can play one of these videos so you get an idea.
It is very energy consuming to cool down data centers, since they become extremely hot. Therefore, companies have started to build data centers at cold locations. For example, Facebook has built a data center in Luleå in Sweden. The cold environment helps the data centers to cool down, simply by opening the windows when needed. Less energy for cooling is now needed, but no excess heat generated from the data center facilities is reused. One reason for this is there are no villages or cities nearby. Instead, we can build smaller data centers integrated into the cities. The cooling systems will then send excess heat generated from the data center facilities to nearby homes and businesses. This makes it possible to recycle generated heat.
So, thank you. So you could see and get an idea of what students can do when they are free to create and they are creating value. This video was done in less than a week, okay, from a student in the course. And I thought it was fantastic, the use of tools that they did. We didn't teach any of these things. We just taught the concept. And other than the concept, everything was developed alone by the student. So, and this was the objective of this task. So giving the opportunity for self-development is one of the important things that we give a lot of importance to. Okay, and with this, I think I can wrap up. So this is a master program, again, in high performance computer systems. You can find more information on this link. So you can Google Chalmers and PHPC and you will get the same link. If you want some more information, you can send me an email. And also there is a reference here to a LinkedIn group, but this is just a pointer to show you what we do for our students and alumni. So we have a LinkedIn group where industrial partners, students, alumni are there. We post our achievements, we post new projects we have, we post job openings and all these things. So it's another tool we offer for our own students. And I think with this,
Pedro,
I
I have a
am
question
open.
about this thing. So,
Yeah.
so you mean to say that those people who are here right now watching us, they are not actually the people that would be joining this group, right?
Not yet.
Yeah, not yet. Exactly. So so once these people that are watching join us at Chalmers and start studying at Chalmers, then they join the
Yes.
LinkedIn group, right?
Yes.
Yeah.
And if I'm allowed, because I got this opportunity to say not yet, I mentioned the word growth mindset. And if you go to YouTube and you type growth mindset, it's very interesting to see what this theory is all about. But just a parenthesis. There was this experiment in a university that said instead of giving fails to students, they would say not yet. So that's why I said the LinkedIn not yet.
Excellent. So that brings me back, and very quickly, just to show you that these links are available and these contact channels are available. If you've already attended any of these webinars or watched any of the recordings, you probably have seen these slides before. I'm just going to run through the motions here and mention them. We have our programs all listed on chalmers.se/masters, and then if you go to /tuition fees, it's tuition fees, /scholarships is scholarships, /meet us is for the events. Universityadmissions.se is where you would have actually made an application, because you should have already made it by now. The deadline was on the 15th of January and will not be opened until much later in April for late applications. So right now, the closest deadline is the 1st of February, and that's a documentation deadline. And for those of you that are non-EU, EEA, Swiss citizens, then you will also need to make an application fee. And that is also, the deadline for that is also the 1st of February. Speaking of that, we will also be having a webinar on Tuesday next week, the 26th of January. At 3 o'clock Swedish time, as usual, with the admissions office. We will be talking about the documentation process, the submission of supporting documents. So if you have any questions about that, you should join that webinar. You can find this information in your email. Actually, you would have received an email. If you've made an application, you have received an email with this. Please check your spam boxes for it. You can chat with us. You can chat with our students. Just scan the QR code or go to bit.ly/chat with Chalmers students. You will be redirected to a web page on the Chalmers website where you can, if you don't already have one, create a profile on this thing called UniBuddy, and then you can chat with the students who are studying different programs, come from different countries. And you can also chat with us because we are there as a staff account, as you can see on the second tab next to students on the picture. Finally, we have our other contact channels. We have our email address, YouTube account, where actually the recording of this webinar will be put up. And then we have our Instagram channel, our blogs and Facebook and all of those other different fields, channels that we've got. Please feel free to join them as long as you feel that you are relevant in that group. Like, for example, the one for Nigeria for WhatsApp is for Nigerian applicants. So anybody else joining that group might not find the information published there useful. That was the end of the presentation. Let's run to the questions now, shall we? So I'll stop the share and let's look at what questions we've got. And if we don't have any, I will ask you some questions myself as well, Pedro. Luigi is asking us, do you accept research or internship proposals also for people currently not enrolled in the university? I mean, to start with, this question is actually not relevant.
This is out of the context, but I can answer. So research and internships, I mean, for example, how should I put, any of these things require a different position that is announced in a different place. So
exactly.
Yeah. And it's exactly, not an open thing. Yeah,
exactly. For Luigi, you need to understand that any position other than okay, let's differentiate this. Positions are jobs.
Mm.
And when you study, when you're doing a master's program, it's not a position, it's an admission, it's a seat. That's the best, right?
Yes.
So
Yes.
you have to make the separation between those two. And internships, research positions, doctoral positions, those are all positions, and hence their employment, in which case you will find that information on the vacancies of the Chalmers website, and you will apply through that part.
Yes.
Contacting Pedro is probably not going to get you anywhere anyway.
No.
Right?
It's going to
Because
give the same answer.
a position needs to be present in order for him to be able to do something about it.
Yeah.
Luigi also asks another question, which I see Vedrana is already typing an answer for. So no, she let it go, so I can pick it up. Does Chalmers offer remote courses in perspective to fulfill requirements for future applicants? Actually, no, Luigi, we don't do that either. So sorry, I'm sorry, we don't do that. So we have the program webpage clearly states prerequisites, right? And the concept of a prerequisite is that you already have it when you apply for it. So we will not be the ones to help you obtain a prerequisite. We've got, okay, so there's a question about documentation. We're not going to pick up on that because that's not relevant to the webinar. I would like to ask you something. You touched upon this subject a little while ago during your presentation. What is something that is super exciting that is happening within your area? Something that your research area, something that's trending or something that's fascinating to you?
Yeah, so I have a problem in that I'm getting excited with many things at the same time. But yeah, I can tell you. So there are a couple of things that are actually, and not only they are super exciting, we are super lucky to have been granted projects to work on this. So this is really good. So we are building a team right now for that. So one of the key things is, like everybody knows today, if you don't say machine learning, deep learning in a talk in our field, it's like I say you are illiterate, right? I mean, machine learning is everywhere, from our phones, our headsets, everything, right? So the question is, so much machine learning anywhere, everywhere, how can we do it better, right? And many people work on the software side of this, but not so many work on, well, many others work, and industry works on the hardware. We have very successful products in the market already, but the gap right now is on working, like I said, on the co-design, on developing something that is worked together from the people that know software very well and the people that know hardware very well. We started this a couple of years ago. We got a PhD course. We are free to do PhD courses at Chalmers in much better way than the master courses, opening new master course, for example. It's much easier to do a PhD course. So at that point, we were dwelling with this, and we said, okay, let's pick up researchers and PhD students from algorithms, deep learning algorithms, and PhD students from computer architecture, put them together in a room, see what happens. And they don't talk to each other. They don't understand the language. This is multidisciplinary. We talk a lot about multidisciplinary. And one of the big barriers for this is that people do not understand the language from the different disciplines.
Right.
So one of the starting things that is actually making this exciting is, how can we start interacting to get better products?
Right.
We need to start talking to each other.
Right,
So
right.
we are now going to be working on a project. This is 12 partners, European partners in a project, and we are part of this, and it's super exciting. So, and we are working on this accelerator.
Do master students get to participate in these projects?
Yes, actually. So not directly, I would say. There is a glitch for it. Actually, it's a very interesting question, because I really want to put master students as much as possible, expose them to all these things, right? In these projects, we have industrial partners, and just like with the master theses, when you get to a partner in industry, there are always some doors that are closed because industry wants to sell products, right? I mean, that's their business. So I cannot really expose what type of product they can give us. So there are some constraints. But what we try to do is to design a parallel thing that is looking exactly at the same research problem, but from a different point of view. And in particular, for this exact project, we have right now a master thesis working with the company actually that is doing in the project, and with me as the supervisor from Chalmers, and we are building up experience to be added to the project.
Right.
I mean, in an ideal scenario, this student will be hired by the company, and then he can do whatever he wants.
True. Wonderful. I would like to continue discussing that, but we've got two really good questions. One of them is a fairly common question that we get when it comes to programs in general. And the question here is, do you think the program is suitable for someone who has 5 years of experience or 5+ years of experience in the software industry?
Yeah, so it's a good question. It's a bit difficult to because there are different aspects here. Okay, experience is a great thing. It puts you. I mean, I have worked with students in my course that were working with Volvo before, and they came in and they could put up questions that not even I would think about because they were in the real world. And us as academics, I mean, I need to be honest here. We live in our world. We are trying to do things for the 20 years ahead, but we don't really know what is happening today in the market, right? I'm sorry, but yeah. But we are going to design the machines that they will be using in 20 years, which is the cool part.
Yeah.
But he would come up with very exciting questions and issues, which would drive us towards this, how to link the research we are doing with the real things that are happening in the world. So having experience is a top quality. Now, the 5 year, it's just a thing that I'm slightly worried sometimes that one person goes to industry for many years, they leave academia a little bit behind. So you'll need to put a catch up in that to know what is happening, what has been happening in the world since then. I think we have like a starting package for that. Like you give some introduction and you give something that will help put people on pace. So I would say yes. The other extra aspect I'm going to say is that just software is not enough for our program. We need to have hardware knowledge too, basic hardware knowledge at least. Because like I said, I mean, we don't want to create the software people. We want to create the combination.
Yeah. And I think it's also important for Rosa. Rosa is the one that's asking the question, for her to understand that it's not the experience is a very small and in fact a weak aspect of your application. If you're applying because you satisfy the prerequisites to start with. If you don't satisfy the prerequisites, then a 5+ year of experience does not necessarily translate into anything valuable that can, offset that. So you really do need to first start by setting yourself up well on the prerequisite side. And then, of course, you can complement that with experience and things like that. And then, of course, those things that Pedro brings up makes your profile look better. But a bad cake will not taste better with good icing. That's the rough analogy I can draw.
Unless you spoon just the icing out. But yeah, no, but no, I don't want to be so negative, but I think you are very factual, and I like to be factual. So the facts are, you are to enter the program, you are judged by your prerequisites, if you satisfy or not. And I get many emails from students. I did this course, I did that. It's not me, okay? So this is the admission office that takes care of this. So I'm sorry, I cannot help you with that. The only thing we set it up was the requirements. Because we need to have a base for students to work. And this is not because we want to be bad people. It's just because you will sit in class and not understand the material that we are delivering. So it's not good for you if you come here with a weak background in a certain thing that we are expecting you to have. So, and that's just it. So what you said is perfectly correct. So if you don't meet the requirements, it's not possible for you to be progressing the way that we want you to progress.
Exactly. And then also
the experience though, so sorry, just a little thing. The experience though, I wouldn't put it as just the icing. It's really important, but it's important for yourself, for your self-growth, for seeing where you are going, and also for contributing a whole lot for the whole. So a student that has no experience but a lot of requirements, and the student that has experience, alone, both of them, probably they are not ideal, but together in class, they make a super,
Great. Yeah,
yeah,
exactly.
a
Exactly.
super portion, you know, it's like
Exactly.
the
And
superpowers we go back.
exactly, the supercomputer
Yeah,
flying.
exactly.
Yes. No, but it's also important for you to know what it is that you want to do also with the 5-year plus experience. Why do you want to then study this program, and what is it that you want to achieve with it is also an aspect.
Yeah, I hear people that are in job and they, okay, let's be honest. Some people are not so happy in the job they are doing and they want to change.
Yeah, exactly.
Some people want to get higher in the job and understand that there are new trends and they want to take a course program to improve the knowledge. And that's very important. So that's very important.
Yeah.
But I think, yes, if you need to nail down one thing is, unfortunately, experience is not evaluated by the admission. So
Yeah.
yeah.
Yeah. Yeah. Jong Ji Lin asks, could you tell us more about the cooperation between quantum computing and this program?
So, very good question. We are all believers of crazy ideas, and this is not to say that quantum computing is a crazy idea, because Chalmers is going to build one, and this is going to be great. But it's a bit futuristic, okay? And the cool thing is we saw this opportunity to work together with them, and we actually had several meetings. We wrote some proposals. Things didn't go yet to the level that we would like, but we are in tight collaboration with them, and there is the opportunity always to do a joint project. So I think one of the greatest things that Chalmers has is that it attracts top research programs worldwide with a very good budget to do incredible things. So when you are at Chalmers, you have opportunities to do a lot of things. And if quantum computing is one of the things that you are crazy about, well, there is a chance to do it. And there is a chance to do it as a combined thesis project, for example, taking a course, getting some more experience, then making a project together with them and seeing where it's going. So this course that they are actually offering, I had a close talk together with the people that will developing the course, and it's a very interesting course for people that don't have any ideas of quantum computing, and they can start getting the basic concepts and see where they can go from here to that place. So I think that's a great. This is not the only thing. I mean, I had a picture of the Chalmers formula, which is okay, not so futuristic, but we have two types of formula. We have the regular one and then the self-driving one. And actually, what I can say, one of our students had taken a course in this Chalmers formula. So, and she was actually doing exactly that picture over there, that nice blue car with the Volvo sign. She was actually working on this team. And this is I think it's a full semester project, if I'm not wrong, and then they compete in an international competition, and it's super cool. I mean,
Yes,
they developed the car and everything that is together with the car, and our student was contributing to this, and I think that's fantastic. Just to have a segue from that, this student is actually doing a thesis now with Volvo on a related topic. So the fact that we are here next door to Volvo, or now it was called Zenuity until yesterday. Well, not yesterday, but Zensac, right? This is a major contributor for the autonomous driving cars. And we have been going in touch with these people. So this is fantastic, I think. I mean, all the ecosystem, I mean, not just what Chalmers attracts as research, but in addition, all the ecosystem of the startups and the industrial poles that we have, like it's fantastic, I think.
I mean, specifically with respect to what we were discussing, you know, like with you suggested, you actually said that that machine learning and these kinds of things are ubiquitous. They're all over, they're all around us, and things like that. I'm wondering how much of it is distributed versus centralized.
So the project that I was talking to you about, one of the partners is, so another big company, but this is not in Göteborg, is Veoneer. So Veoneer is a part of the project. I think it's in the next slide. It's called Vedliot. Veoneer was also a spin-off of Volvo and is now also working on self-driving systems. And in the project, what they are actually looking is what you are talking about, is how can they distribute the processing of this deep learning in different places. So I talked about computing continuum, and we talk about this when we have sensors in the car, right? We have radars, and well, they are called lidars, but we have cameras, we have radars, we have rain sensors, a whole lot of stuff. And you can put computation directly on the sensor, or in the computer in the car, or in the computer in, for example, a GSM base station or a 5G base station, or in a data center in Gothenburg, or a data center in the US. Now, the question is, when you have a passenger, when you have a pedestrian in front, can you contact the data center in the US and ask, what should I do now? Please help me. No, that's not going to work, right? So you need to know where are you going to partition, like this distribution of work that you were saying, extremely important. How are you going to partition these things? Okay. Yeah. And
do you think this connection that we have with quantum computing would actually be very, very instrumental in this aspect?
So my knowledge of quantum computing right now is not that high. I see the opportunities that are there, and I'm more, so I'll tell you, we were more looking at quantum computing. So right now has one little glitch, is that the reliability of the operation. So they do an extreme amount of computation, but they have to be in these very low temperature environments, right? I don't want to say 0 Kelvin, but it's very low temperature, and they do the computations inside, and then they have to poke and see, oh, what is the result? And these things are a bit unstable. And in our field, we have worked a lot on reliability, even for memories. I talked about space. Right? When you take a processor with memory to space, bombarded with solar flares that will change the memory that is inside. We were thinking in this project to think at similar issues for the quantum computing. Can we apply some of the concepts we have in the real computer architectures that we are doing today for the quantum computers? And there is a trend on doing some sort of hybrid machine out of that. And this is what we were trying to exploit, actually.
Interesting. Yeah. Well, it looks like, Pedro, we do not have any further questions.
Even though I could stay here all day talking about our cool
exactly
stuff.
Yeah, I'm actually super excited. I want to be able to study these programs. The thing is, I've spent 8 years speaking about the programs at Chalmers, and I wish that I could study every one of them. Problem is, I don't have the prerequisites. Now, I'm myself shooting myself in my
We need to do something about that.
Yeah, I'll have to go do like 17 bachelor's degrees first, but we'll see. We've got 2 minutes left. We really don't have anything else to discuss. So I think we can more or less wrap this up. I'm going to bring up the contact page once again, just to be able to give everybody a last chance to see the slide and take a picture if they want to. I'm going to put you on the side over here. Let us see. So this was the contact a student slide. You can take a picture if you want to, or scan the QR code immediately. Get in touch with our students, or with us for that matter. You can get in touch with us through our social media and all our other contact channels that we've got. We have specific channels for some countries, for example, Indonesia and Thailand, Nigeria, Brazil, and Uganda. And that brings us to the end of the presentation. I would like to thank everybody that attended today's webinar. I would like to thank Pedro, you, for your time and your sense of humor and the presentation. Do you have any final words, Pedro, before I sign off?
Apply.
Okay, well, I've already done so. So please make sure you upload your documentation, or you submit your documentation according to the requirements from where you have your degree. With that, I'd like to wish you all a good rest of your day. Stay safe and healthy. This was Chalmers University of Technology. Goodbye.
Thank you very much.